guys, welcome to virtual week 2 of learning with Miss Jones. This week we'll be studying some astronomy, and there'll be 3 categories for today's lesson. Pretty cool people, movements of the earth, and lastly, parts of the moon. So what is astronomy? Astronomy is simply the science of the universe, where we talk about space and all of its laws. And astronomy was first studied in Greece. In Greece, you can thank them for a couple of things, such as geometry and trigonometry. Fun! So to start you off with some pretty cool people, let's talk about Aristotle. This guy is old, born in 300 BC. He was the first to believe that the earth was round because its shadow was round when it passed through the sun. And so you look on the ground, you see a round circle, you think the earth is round. Pretty good observation there, Aristotle. Of course, his theories were disregarded at some point later. This next guy, his name was Eratosthenes. I had to look that one up. I didn't know how to pronounce it. But he was the first one to calculate Earth's circumference. His guess was 39,000 kilometers. And he was pretty close. It's really 40,075 kilometers, so congrats to him for 200 BC. When we talk about the origins of astronomy, please keep in mind that these scientists were observing things almost 2,000 years ago. So some are going to be wrong, but a lot turn out to be right. So just keep that in mind. The first model that came about was the geocentric model, and that model was saying that the Earth is the center of the universe. To you and me, that may sound crazy. However, that was widely believed until the 1600s. It was only 400 years ago. The truth is, the sun is the center of the universe, and we call that the heliocentric model. Everything revolves around the sun. So in 140 AD, a guy named Ptolemy said that, stars don't move in the sky, but planets do. So he concluded that planets are actually much closer than stars, and we can see them move. He also observed and tried to explain the backward motion of planets, which we call retrograde motion. No, we don't. We call it retrograde motion. My bad. He said they appear to move in a backward rotation, so therefore we call it retrograde motion. And he said that because each planet travels around the sun at different speeds. Kind of like racers on a track in different lanes. Another cool guy that you know about in astronomy is a guy named Copernicus. Now he's not as old, this is 1500 AD, but he was the one who said the heliocentric model that the sun is the center of the universe. It took some time to convince people that the sun was the center since they had believed for so long that the earth was, but Copernicus finally got them to believe that. The only thing Copernicus said that people do not agree with is the fact that the earth moves around the sun in a circle. It's kind of a circle, but really it's called an ellipse. We'll get to that later. Back in 1600, a guy named Bra, I'm guessing that's how you say his name, he made many measurements of the planets moving. And his data was used to develop our theories today. About 30 years later in 1630, a guy named Johannes Kepler came into the picture. He put Bra's data to good use. Maybe I should just call him Bra. But Kepler developed 3 laws of planetary motion that still stand today. The first law states that planets orbit the sun in an ellipse instead of a circle. And he developed a term called astronomical unit, which is how far away the sun and earth are from each other. His second law says planets move fastest when they're in orbit closest to the sun. Aphelion means that the earth is farthest away from the sun, and this takes place in July, even though it's really hot in July. And perihelion is when the earth is closest to the sun, and this takes place in January, although it's really cold. The third and final law says the farther away a planet is from the sun, the longer it's going to take to orbit entirely around the sun. That makes sense though. 10 years later, a guy named Galileo comes into the picture. And this is 1640. He was the first one to use a telescope to look up into space. How cool is that? Here's what he discovered. There are 4 moons of Jupiter. Planets are planets, not stars. Venus has phases like the moon. Moon's surface is not smooth. And the sun has sunspots. Those are amazing discoveries back in 1640. Wow. And then in 1700 you hear of a guy named, Newton. He's a pretty big deal. And he's the one that gives us the law of gravity. That law of gravity also applies in space. Gravity describes what holds the moon in orbit around the earth. And it also describes why we don't float away. Now on to our final segment of the day, which is going to be talking about moon's features. All of this information we gathered from the Apollo missions that took place between 1969 and 1972, where we sent 6 teams up into space. Kinda crazy when you think about it. They discovered that the moon is less dense than the Earth, and gravity is about 1/6 of what it is here on Earth. AKA, a 150-pound person on Earth would only weigh 25 pounds on the moon. The temperature during the day is about 225 degrees Celsius. Whew, that's hot. But at night, it's negative 307 degrees Celsius. Daylight and darkness each last about 2 weeks on the moon. They also discovered the moon has no atmosphere, no water, and no sorts of weathering and erosion. The surface of the moon contains craters, these round, deep, big, huge depressions that are in the moon. These craters form from the fast-moving impact of debris. Craters can be as large as 150 miles in width. That's huge! The moon also has highlands, and these are pitted light-colored areas of the moon. Ever heard of the man in the moon? You can see all the different shades of the moon. There's some color to it. It's not all just one color. But these highlands are showing us that the moon actually has mountain ranges. That's pretty cool too. The smooth, dark areas of the moon they call Maria. That's my mom's name. But that formed from plains of dark ballistic lava. Early astronomers thought those dark areas were actually bodies of water. Now wouldn't that have been something? The moon has regolith, and that's the layer of dust and rock that cover the surface of the moon. Of course we had to drill down and see what the interior of the moon was going to be like, so we can figure out what this thing is. They said the core is solid but smaller than that of Earth. It could be possibly made of iron or metal. The moon is thought to be about the same age as Earth. And of course, you know we have to have a hypothesis on how the moon was created. We call it the giant impact hypothesis. The giant impact hypothesis says that the moon was once a part of the Earth. Then a collision took place with a giant meteor of some capacity and it hit the Earth, and then a part of the Earth broke off, and that's how the moon was created. That was a little dramatic. So that wraps up week 2 of Learning with Miss Jones. I hope you enjoyed today's lesson. If you have any questions or comments, please let me know. Until then, see you guys next week. I'm out.